Now we want to look at the reciprocal trig functions of sine and cosine, which you know is cosecant and secant. And we got to look at some characteristics of reciprocals. What happens when you flip numerators and denominators? So let's start by looking at the sine and cosine graphs. I just drew a quick sketch here of what sine and cosine look like. Sine, remember, goes through 0, 0 and repeats every 2 pi units. So for sine, we have a hill and a valley every 2 pi. Cosine starts at the point 0, 1. And once again, we've got this hill and valley idea. But if I go from 0 to 2 pi, I go down the hill, in the valley, then back up. That completes one cycle of cosine. And you can see there I've also labeled some of our relative extremas, the maximums and minimums along the way. So here we've got some maximums and minimums that we're going to look at. So when we look at reciprocals, we put 1 over every single value that is on the graph. And as soon as you do that, what do you need to be concerned for? And we need to be concerned for zeros in the denominator. And the reason we need to be concerned with zeros in the denominator is that's undefined. We can't have those points. So where do we get undefined points on the graph? If I look at the sine, I'm going to have undefined points wherever I've got a 0 value. So ultimately right here, this negative 2 pi, this negative pi, this 0, this pi, this 2 pi, those all have outputs of 0. So if I take the reciprocal, those are going to be undefined. 1 over 0 is undefined. So for the cosecant, it's going to be whenever the sine value is 0. If we look at the secant, it's going to be where the cosine value is 0. So every single point here where the graph crosses the x-axis is going to be undefined. What other values are very easy to determine for secant and cosecant? Well, remember secant and cosecant are reciprocals of sine and cosine. So the easiest ones to work with are all these values of 1, the maximums and minimums. Because if I take the reciprocal of 1 or negative 1, the answer is still 1 or negative 1. So here we're looking at the relative extremas, 1 and negative 1s. What are the x-intercepts of secant and cosecant? Well, if you remember from the unit circle, secant and cosecant are always larger than or equal to 1. They always either touch the unit circle or expand beyond the unit circle. So there's no 0 values. So x-intercepts for secant and cosecant, they don't exist. There is never a distance of 0 for secant or cosecant. Where does the function increase or decrease? Well, you can see that on the cyclic pattern, we've got an increasing function here from negative pi up to 0. We've got it from negative 1 up to 2 pi. So it really repeats every pi units that we've got this increase or decrease. And then once again, what quadrants is each function, positive or negative? We just want to have that in the back of our mind are all students take calculus. And for the cosecant of theta, it's going to be positive in 1 and 2 because cosecant is tied to sine. And then for the secant of theta, it's going to be positive in 1 and 4 since that's tied to cosine. Now if I want to draw a quick graph of these functions, y equals the cosecant of x and y is equal to the secant of x, I know that the cosecant is the same thing as 1 over the sine of x. So I'm going to look at the reciprocal values for sine. As I said up here, there's a couple things we want to look at. The first thing we look for are zeros for the sine graph. And I know that if I have my sine graph, up here I've got negative 2 pi, 0 pi, and 2 pi end up being zeros. If I take reciprocals of all those, I get undefined points, or asymptotes. So if I'm going to graph out the cosecant, originally these values were zeros in sign, but now if I'm putting 1 over 0, that's going to be an undefined point or an asymptote. So each of these values turn into asymptotes. The next thing I looked at is what other points are really easy to determine for secant and cosecant. And it was the relative extrema. Because if I had a value of 1, the reciprocal was still 1. So if I look back up here, at pi over 2 I had a positive 1. At 3 pi over 2 I had a negative 1. So here at pi over 2, I'll go up to a positive 1. And at 3 pi over 2, I go down to a negative 1. And if I follow the same pattern, negative pi over 2 is going to be negative, negative 3 pi over 2 is going to be positive. So it's a positive, negative, positive, negative. The last piece that I said is that there are no x-intercepts with secant and cosecant. They don't exist because the distance on the unit circle for secant and cosecant is greater than or equal to 1. So I know for my graph it cannot come down here along the asymptotes, because if I were to come down at this point, I would cross the x-axis, which means I've got a 0 value. That's not the case. So we know that this graph has to curve upwards along the asymptote. Down here then, I know that this piece can't go up, because if I were to go up there, you can see I would cross the x-axis, which would be a solution. And we've got no x-intercepts. So I've got to come down with this piece. Third piece goes up, and you can see the pattern of up, down, up, down. And there's my cosecant graph. I can do the exact same thought process with secant. Looking back up here, I can see I've got zeros at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. So at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2, these all become asymptotes. Because on cosine, the reciprocal function, these were all 0 values. If we go back up here, we can see at 0 we had a value of 1. At pi we had a negative 1. Negative pi was negative 1. So I can go here, and I know 0 we're at 1. At pi we're at negative 1. And it's going to follow the up-down pattern as well. Here at negative pi we're at negative 1, and then at pi we're at positive 1. And once again, secant does not have any x-intercepts, so that means my graphs have to curve upward and downward. So there's my secant and cosecant graph. Asymptotes and your maximums and minimums, coupled with the idea that there are no x-intercepts, help with our graph.